Right now, above our heads, the sun burns with unimaginable power. But hidden in its fiery heart is a countdown, a ticking clock to the end of everything we know. The sun is dying, and when it does, the universe around us will never be the same. Welcome to Starsky Science, where we explore the deepest mysteries of the cosmos. If you love learning about the secrets of our universe, make sure to subscribe and be part of our growing community. The sun feels eternal. Every morning, it rises. Every evening, it sets. It has done this for billions of years, and to us, it seems like it will continue forever. But scientists know the truth: the sun is not immortal. It is a star, and like every star, it was born, it has a lifespan, and one day, it will die. NASA scientists and astronomers from around the world have spent decades studying the sun's structure, its nuclear processes, and its ultimate fate. And what they have discovered is both fascinating and terrifying. To understand the death of the sun, we must first understand its life. At its core, the sun is a nuclear fusion machine. Every second, it converts around 600 million tons of hydrogen into helium, releasing an almost unimaginable amount of energy, enough to power civilizations 1 trillion times larger than ours. This process is what gives us sunlight, warmth, and the stable climate that allows life to exist on Earth. But this energy doesn't come without limits. The hydrogen fuel inside the sun's core is not infinite. Slowly, atom by atom, the sun is burning through its reserves. And scientists calculate that one day, those reserves will run dry. The sun is about 4.6 billion years old, nearly halfway through its total life expectancy. Based on stellar models, astronomers predict it has about 5 billion years left before its death. That may sound like an eternity, but in cosmic terms, it's the blink of an eye. And when the sun begins to die, the transformation will be catastrophic. First, it will exhaust its core hydrogen supply. When this happens, the balance between gravity pulling inward and pressure pushing outward will break. The sun's core will collapse, heating up to extreme levels, while the outer layers expand. Our star will grow into a red giant, engulfing Mercury, Venus, and possibly even Earth itself. This is not speculation. We know this from observing other stars. Astronomers have studied dying stars across our galaxy, giants swollen with unstable energy, shedding their outer layers into space. And those stars show us what awaits our own sun. But before the sun reaches its final collapse, Earth will already face devastation. Even before the red giant phase, the sun's growing brightness will boil away our oceans. According to scientists at NASA's Goddard Institute, in about 1 billion years, Earth will become uninhabitable due to runaway heating. Our planet's surface will transform into a scorched desert, stripped of oceans, atmosphere, and life. So while the sun may have billions of years left before its death, humanity, and any form of life on Earth, faces extinction much sooner. And here is the terrifying part: the sun's death is not a quiet event. It is a cosmic catastrophe. After swelling into a red giant, it will shed its outer layers, creating a glowing shell of gas called a planetary nebula. What remains of the sun will shrink into a dense, faint ember, a white dwarf, no larger than Earth but containing nearly half the sun's current mass. Imagine that, the star that once lit up our world, reduced to a small, fading cinder in the dark. But the story of the sun's death doesn't end with its collapse. Its death will reshape the entire solar system. Planets will be thrown into chaos, orbits destabilized, and moons ejected into deep space. The delicate balance that holds our cosmic neighborhood together will be shattered. And yet, even in this destruction, there is beauty. The gases expelled by the dying sun will drift across space, seeding the galaxy with elements that can form new stars, planets, and perhaps even life elsewhere. In a way, the sun's death is also a rebirth, a recycling of cosmic material that fuels the universe's endless cycle of creation. This paradox, that the sun's end will mean both death and renewal, is what makes its story so haunting. Now, let's go deeper into the science of the sun's lifespan. Scientists from institutions like NASA, ESA, and observatories across the world have studied how stars evolve, and their discoveries reveal astonishing truths about our own star's future. The sun may appear calm when we look at it in the sky, but in reality, it is one of the most violent and unpredictable objects in our cosmic neighborhood. It is not a steady, perfect ball of light, it is a roiling sphere of plasma, constantly boiling, shifting, and erupting with energy. And the clues to its death are hidden in this restless activity. Scientists at NASA's Solar Dynamics Observatory and the European Space Agency have studied the sun's surface in extraordinary detail. What they see is astonishing: a living, breathing star, its surface alive with solar flares, sunspots, and coronal mass ejections. These violent outbursts are not just spectacular, they are warnings of the sun's unstable nature. Every solar flare is like a bomb, releasing as much energy as billions of nuclear weapons. Every coronal mass ejection hurls billions of tons of plasma into space, capable of disrupting satellites, power grids, and communication systems on Earth. In fact, in 1859, the world experienced the Carrington event, the most powerful solar storm in recorded history. Telegraph wires caught fire, compasses spun wildly, and the skies lit up with auroras as far south as the Caribbean. If such a storm struck us today, it could cause trillions of dollars in damage and take years for humanity to recover. Now imagine the future, when the sun grows even more unstable. As it runs out of hydrogen fuel, these storms will intensify. Its magnetic fields will twist into chaos, producing super flares that could scorch entire worlds. NASA astrophysicists predict that during the later stages of the sun's life, these eruptions will become far more destructive, sending shockwaves of energy across the solar system. But the changes won't just affect space weather. They will transform the very fabric of our solar system's architecture. Right now, Earth orbits at the perfect distance from the sun, inside the so-called habitable zone, where liquid water can exist. But over time, as the sun grows hotter and brighter, this habitable zone will drift outward. In just a few 100 million years, Earth will no longer be within this safe region. Our planet will begin to resemble Venus, with a suffocating atmosphere, runaway greenhouse effects, and surface temperatures high enough to melt metal. This is not mere speculation, it is a reality written into the physics of stellar evolution. Observations of other planetary systems reveal that stars in their later stages make once habitable worlds unlivable. Astronomers studying red giant stars see planets scorched, atmospheres stripped, and orbits decayed into chaos. Earth's future will be no different. What will happen to the outer planets as the sun changes? Jupiter, Saturn, Uranus, and Neptune will not escape unscathed. Their icy moons, some of which may harbor subsurface oceans today, will be transformed. Europa and Enceladus, for example, are considered promising places to search for alien life, hidden beneath their frozen shells. But as the sun swells, these icy worlds may melt on the surface, temporarily creating liquid oceans exposed to space. For a brief time, these moons might experience surface habitability, before the sun's fury ultimately destroys them. Think about that, our solar system, briefly lit with strange new oceans on moons far from Earth, before collapsing into chaos. When the sun enters its red giant phase, its radius could extend out as far as Earth's orbit, or beyond. The debate among scientists is whether Earth will be consumed entirely or left as a lifeless, scorched husk. Recent simulations by astrophysicists suggest that drag from the sun's outer atmosphere could pull Earth inward, sealing its fate in fire. Others argue Earth may narrowly survive, orbiting a swollen, fiery sun from just beyond the edge. Either way, the Earth as we know it will be gone forever. At the same time, Mars, our cold, dusty neighbor, might enjoy a brief golden age. As the sun grows larger and warmer, the habitable zone will shift outward. Mars, once frozen and barren, could thaw. Its polar ice caps might melt, releasing water, and its surface could warm enough to allow rivers and lakes to form once again. For a short time, Mars may become the most Earth-like world in the solar system. But this reprieve will be temporary. The sun's instability will not last long in cosmic terms. Mars's fleeting habitability will vanish as the red giant continues to swell, eventually burning it too. For humanity, this raises profound questions. Will we still exist by then? If we survive as a species long enough, perhaps we will have colonized Mars, the moons of Jupiter, or even other star systems. Some scientists argue that if humanity is to survive the sun's death, we must become an interstellar civilization, a species that can move beyond our dying star and seek refuge among the stars. This is not just science fiction. NASA and other space agencies are already taking the first steps toward this future, exploring propulsion systems, searching for habitable exoplanets, and studying how life might survive beyond Earth. Because in the grand scheme of things, we are living on borrowed time. Now, let's turn to the deeper physics of the sun's core, the true engine of its life and its death. Inside the sun's center, at temperatures of 15 million degrees Celsius, protons smash together in nuclear fusion reactions. This is where hydrogen is converted into helium, releasing gamma rays that slowly fight their way outward. But here's something astonishing: the light you see from the sun today was not created in the last second. The photons produced in the core take thousands, sometimes even millions of years, to reach the surface. That means the sunlight warming your skin right now began its journey before humans even existed. But eventually, this process will falter. Once the sun exhausts its hydrogen, its core will contract, heating even further until helium fusion begins. This phase is unstable and short-lived compared to the long, steady hydrogen-burning stage. The sun will begin to pulsate, expanding and contracting like a dying heartbeat. During this transformation, the sun's outer layers will be shed into space, forming a vast glowing shell of gas. This will be the planetary nebula phase, one of the most breathtaking phenomena in astronomy. We see these objects scattered throughout the galaxy, glowing like cosmic flowers. The Ring Nebula, the Helix Nebula, the Cat's Eye Nebula, all of them are stars like our sun, caught in their final moments of beauty. One day, our sun will create such a nebula, a brilliant but short-lived spectacle before fading into darkness. At the core of that nebula will be what remains of our star, a white dwarf. White dwarfs are among the strangest objects in the universe. They are stellar corpses, hot, dense, and compact, no larger than Earth yet with masses half that of the sun. A teaspoon of white dwarf material would weigh tons. And though they no longer burn fuel, they glow faintly from leftover heat, slowly cooling over billions of years. This is the sun's final destiny, not to explode as a supernova, as massive stars do, but to fade silently into a cold, dark remnant. Eventually, after unimaginable timescales, it will become a black dwarf, a dead star radiating no light at all. When scientists at NASA describe this process, they often emphasize its duality, destruction and creation. For while our sun's death will mean the end of Earth, it will also scatter elements across space. The carbon, oxygen, and other heavy elements in its outer layers will drift into the galaxy, enriching interstellar clouds. From these ashes, new stars and planets will form. In fact, everything we are, our bodies, our world, even the sun itself, was born from the remains of stars that died long ago. So in a sense, the sun's death is not an ending, but a continuation of the universe's grand cycle of birth, death, and rebirth. And yet, when we reflect on what this means for us, it is sobering. Humanity's entire history is just a flicker compared to the sun's lifetime. Civilizations rise and fall in mere moments, while the sun continues its slow, inevitable march toward death. This realization forces us to confront questions not only about science, but about our place in the cosmos. What will humanity do with the time we have left? Will we stay confined to one fragile planet, doomed to vanish when the sun grows too bright? Or will we spread across the stars, ensuring that some part of us survives long after the sun's light has faded? If you're fascinated by these deep questions and the incredible science behind them, make sure you're subscribed to Starsky Science. Our universe is full of mysteries, and together, we'll uncover them. The story of the sun's death is not just a tale of destruction, it is also a story of science, discovery, and the remarkable ways humanity is learning to understand the cosmos. The more we study our star, the more we realize it holds the answers to some of the deepest questions about the universe. Astronomers have long wondered, how do stars live, and how do they die? To answer this, scientists look beyond our sun, studying other stars at different stages of life. Through telescopes like Hubble, Chandra, and now the James Webb Space Telescope, they observe stars much younger, much older, and far more massive than our own. These stellar laboratories give us a glimpse of what awaits the Sun in the distant future. One of the most fascinating discoveries is that stars die in many different ways, depending on their mass. Massive stars end their lives in violent supernova explosions, collapsing into neutron stars or black holes. Smaller stars, like our Sun, face a quieter fate, expanding into red giants before shrinking into white dwarfs. This diversity in stellar death shows us that the universe is full of endings, and each ending leads to a new beginning. NASA astrophysicists explain it this way: stars are the engines of creation. They forge elements in their cores, release them into space when they die, and provide the raw material for new stars, planets, and even life itself. Without dying stars, there would be no Earth, no oceans, no trees, and no people. In a very real sense, we are the children of dead stars. But while the Sun's eventual death may sound far away, the signs of its aging are already measurable. Scientists have detected subtle changes in the Sun's brightness, its magnetic cycles, and even the flow of particles in the solar wind. These clues help researchers refine their models and predict the Sun's long-term future with greater accuracy. One of the most exciting tools for studying the Sun today is the Parker Solar Probe, launched by NASA in 2018. This spacecraft is flying closer to the Sun than any probe in history, literally touching the Sun's outer atmosphere, the corona. It has already sent back groundbreaking data, revealing details about the solar wind, magnetic fields, and the turbulent environment around our star. The Parker Solar Probe is helping us understand how stars work, and how they eventually fail. And then there's the Solar and Heliospheric Observatory, SOHO, which has been watching the Sun for decades. Together with other missions, SOHO has provided a continuous record of solar activity, allowing scientists to study the Sun's 11-year cycle of sunspots, flares, and storms. These cycles may seem small compared to the Sun's ultimate death, but they are pieces of a much larger puzzle. Every flare, every storm, every shift in the Sun's activity is a reminder of its dynamic nature. Now, let's imagine a scene billions of years from now. The Sun has grown unstable, its outer layers expanding into space. Earth, if it still exists, is unrecognizable, a dry, scorched wasteland. But further out, on the icy worlds of the outer solar system, something remarkable may be happening. Moons like Titan, Europa, and Ganymede could briefly become habitable. Titan, with its thick atmosphere of methane, might warm enough to melt its frozen lakes into oceans of liquid water. Europa's icy crust could crack open, exposing its vast underground ocean to sunlight for the first time. For a fleeting cosmic moment, life might bloom in places that were once frozen and dark. This is one of the great ironies of stellar death. While the inner planets are destroyed, distant frozen worlds may briefly awaken. For scientists, this opens fascinating questions about the potential for life beyond Earth. Could alien civilizations exist around dying stars, thriving in that temporary window of habitability? Could this be a stage in the life cycle of planets across the universe? To answer such questions, astronomers look for exoplanets around white dwarfs. And incredibly, they found them. In 2020, astronomers discovered the first intact planet orbiting a white dwarf star. This shows that not all planets are destroyed in the death of a star. Some survive, clinging to faint remnants of their parent. Others are torn apart, their fragments forming disks of debris that circle the white dwarf like cosmic tombstones. This discovery shocked scientists. It means that the aftermath of a star's death is not just silence, but a chaotic rearrangement of planetary systems. And if planets can survive around white dwarfs, could life survive there too? These are not just abstract questions. They are part of humanity's quest to understand whether life could exist elsewhere in the cosmos. Now, let me ask you a question. Globe showing Europe, Africa. If humanity could escape the dying sun and settle on another world, which planet or moon in our solar system do you think would give us the best chance of survival? Backhand index pointing right, tell us your answer in the comments, we'd love to hear your thoughts. And if you're enjoying this deep dive into the future of our sun, don't forget to like this video. It helps more people discover these incredible cosmic stories, and it tells us that you want more documentaries like this from Starsky Science. As we think about survival, scientists are also asking whether advanced civilizations elsewhere in the universe have faced the same challenge. Every star eventually dies, which means every intelligent species must confront the same problem we will one day face: how to outlive their own star. This idea leads to one of the most fascinating concepts in astronomy, the Dyson sphere. Proposed by physicist Freeman Dyson, this is a hypothetical megastructure built around a star to capture its energy. If advanced civilizations exist, they might use such structures to survive as their stars evolve, harnessing every photon of light before it fades away. Astronomers have even searched for signs of Dyson spheres, scanning the skies for unusual patterns of starlight. Though none have been confirmed, the search continues, raising profound questions about our future. Could humanity one day build something like this? Right now, it sounds impossible. But then again, only a century ago, sending humans to the moon seemed impossible. Science has a way of turning dreams into reality. If survival requires it, perhaps one day humanity will attempt feats we can barely imagine today. Meanwhile, telescopes continue to reveal the universe's secrets. The James Webb Space Telescope has already begun studying dying stars with breathtaking clarity, revealing details of planetary nebulae and the atmospheres of white dwarfs. These observations not only confirm our theories, they also challenge them, forcing us to refine our understanding of how stars evolve and die. The more we look, the more we realize the universe is both predictable and surprising. We know the sun will die. We know roughly how it will happen. But the details, the fate of each planet, the survival of moons, the reshaping of the solar system, still hold mysteries we are only beginning to uncover. And perhaps the greatest mystery of all is this: what will happen to us? Will humanity vanish with the Earth, just another casualty of stellar death? Or will we rise to the challenge, becoming a species that outlives its parent star, carrying our story into the galaxy? One thing is certain: the countdown has already begun. When we talk about the sun's death, we often imagine it in broad strokes: a glowing red giant, Earth engulfed, and finally a white dwarf drifting in space. But in reality, the details are far more intricate, and scientists have developed sophisticated models to simulate every stage of this transformation. Astrophysicists use supercomputers to recreate the physics of stellar evolution. These simulations track the fusion processes inside a star's core, the changing balance of forces, and the flow of energy outward. By comparing these virtual models with observations of real stars at various stages, scientists can refine their predictions about the sun's exact fate. One key aspect of these models is the role of neutrinos. Neutrinos are ghostly subatomic particles, produced in the heart of stars during nuclear fusion. They rarely interact with matter, which means they pass through planets, people, and even entire galaxies almost undisturbed. Trillions of them are passing through your body right now, without you even noticing. During the sun's normal life, neutrinos stream out steadily, providing a subtle but measurable signature of the fusion process. But as the sun nears its death, its neutrino output will change dramatically. For massive stars, a sudden burst of neutrinos is one of the earliest signs of collapse, arriving hours before the visible explosion. For stars like the sun, the process is slower, but neutrinos will still serve as one of the first cosmic messengers of its changing state. To detect these elusive particles, scientists have built enormous underground observatories, like Super Kamiokande in Japan and IceCube in Antarctica. These facilities monitor giant tanks of water or ice, waiting for the rare moment when a neutrino collides with an atom, producing a faint flash of light. When the sun's fusion begins to falter billions of years from now, these detectors, or their future equivalents, will record the story long before the sun visibly changes in the sky. But neutrinos are only part of the picture. Another profound effect of the sun's death will be gravitational weakening. As the sun sheds its outer layers during its red giant phase, it will lose a significant fraction of its mass. This loss will reduce its gravitational grip on the planets, causing their orbits to expand outward. In simulations, Mercury and Venus spiral into the sun's fiery atmosphere, while Earth teeters on the edge of survival. If the sun expands slightly more than expected, Earth too may be consumed. But if it expands less, Earth could escape, drifting further into space on a wider orbit. In either case, the Earth will no longer be the blue and green jewel we know, it will be a lifeless, scorched relic. For the outer planets, however, this loss of solar mass means freedom. Jupiter, Saturn, Uranus, and Neptune will slowly drift outward, their moons carried along with them. In the far future, the solar system may look less like a neat family of planets and more like a scattered clan of wandering worlds, loosely bound around a fading white dwarf. Now, here's a fascinating thought: the sun's death will not be a local event only. From across the galaxy, distant civilizations, if they exist, could witness its transformation. Just as we study dying stars light years away, intelligent beings elsewhere might one day observe the sun as it swells into a red giant. Astronomers use a technique called spectroscopy to study stars. By splitting starlight into its component colors, they can detect the fingerprints of elements, temperatures, and activity. If alien scientists have been watching our sun for centuries or millennia, they may already know more about its future than we do. They would see the gradual shifts in light output, the signatures of solar wind, and eventually the spectral signs of mass loss. Imagine, somewhere across the galaxy, a civilization debating what will happen to the little yellow star we call the sun. To them, it is not just an object of study, it is a neighbor, a distant spark of life. Could they be watching, waiting, perhaps even wondering whether humanity has survived? This possibility highlights an important truth: the universe is full of endings, and each ending is visible across vast distances. A star's death is not silent, it is broadcast in light, neutrinos, and gravitational waves, carrying its story to every corner of the cosmos. And this raises an even deeper question. If other civilizations can witness our sun's death, could we one day witness the deaths of stars with inhabited planets? Could we recognize the signs of a civilization struggling to survive its own star's decline? These are not questions with easy answers, but they remind us that our story is part of a much larger cosmic drama. As the sun transitions into a red giant, its atmosphere will become unstable, blowing off massive streams of gas into space. These will form a planetary nebula, a glowing shell of ionized gas illuminated by the sun's exposed core. Planetary nebulae are among the most beautiful sights in astronomy, colorful, intricate shapes shining like cosmic flowers in the dark. One day, billions of years from now, our solar system will host one of these breathtaking displays. Astronomers have observed planetary nebulae for centuries, but modern telescopes reveal astonishing details: wisps of gas shaped by magnetic fields, knots of material sculpted by stellar winds, and delicate filaments stretching for light years. Each one tells the story of a star's final breath. When the sun becomes such a nebula, it will mark both an ending and a beginning. The material it releases, carbon, oxygen, nitrogen, will drift into the interstellar medium, becoming part of the raw material for future stars and planets. Long after Earth is gone, fragments of its atoms may help build new worlds, new oceans, and perhaps new forms of life. In this sense, the sun's death is not a tragedy but a transformation. It is the continuation of the cosmic cycle that gave rise to us in the first place. We are stardust, and one day, our own star will return its elements to the galaxy, ensuring that the cycle continues. But before that happens, humanity will face a choice. Do we remain on Earth, bound to the fate of the sun? Or do we expand outward, becoming a spacefaring civilization capable of outliving our parent star? This question is not just about science, it is about destiny. As the sun swells into a red giant, the changes to Earth will be nothing short of catastrophic. Long before the sun engulfs our planet, the slow increase in brightness will already be transforming everything about our world. Scientists estimate that even a modest increase in solar luminosity, just 10% higher than today, will be enough to strip away oceans, shift climate systems, and erase the delicate balance that has allowed life to thrive. Water, our most precious resource, is among the first casualties. As the sun brightens, evaporation from oceans and lakes will accelerate. The atmosphere will become heavy with water vapor, itself a greenhouse gas, amplifying the warming effect. Eventually, Earth will enter what is known as a moist greenhouse state. In this stage, oceans begin to boil, clouds thicken, and the sky takes on a suffocating humidity. It sounds like a scene from a nightmare, but it's a process we can already glimpse elsewhere in the solar system. Venus, with its crushing atmosphere and runaway greenhouse effect, offers a preview of Earth's distant future. At some point, the similarities will be unavoidable. Earth will look less like the lush blue planet we know and more like a boiling, cloud-wrapped Venus. The oceans, once teeming with life, will shrink into steaming seas, their waters lost to space as the upper atmosphere breaks apart under the sun's ultraviolet radiation. Molecules of water will split into hydrogen and oxygen, and the lightweight hydrogen will escape into space. Slowly but inevitably, Earth will be stripped of its water entirely. This desiccation will leave behind vast salt flats where oceans once stretched, cracked landscapes where rivers once ran, and deserts where forests used to stand. Mountains will remain, but their slopes will be baked dry. Volcanoes, if still active, will pour lava into an atmosphere already dense with carbon dioxide and oxygen, a toxic mix for most forms of life. What of life itself? It will struggle to adapt as conditions worsen. The earliest victims will be large animals and complex ecosystems, unable to cope with the rising heat. Microbial life, however, may endure for far longer. Extremophiles, organisms that thrive in extreme environments, might find refuge in underground aquifers, deep in the crust, or even in clouds high above the scorched surface. Some scientists believe that microbial life on Earth could persist until the very last days before the sun's final expansion. But the planet itself will not be spared. As surface temperatures climb into the hundreds of degrees Celsius, rocks will crack, soil will burn, and minerals will transform. The delicate cycle of plate tectonics, which drives earthquakes and builds mountains, may slow or halt entirely as the planet loses water, which lubricates the movement of plates. Without tectonics, Earth's surface will become geologically stagnant, barren and lifeless. Meanwhile, the sun's atmosphere will begin to touch Earth directly. The solar wind, a constant stream of charged particles, will intensify, stripping away what remains of the atmosphere. Protective layers like the ozone will vanish, leaving the surface exposed to lethal radiation. At this point, Earth's fate may diverge depending on the precise physics of the sun's expansion. If the sun swells just slightly more than predicted, Earth will be consumed entirely. Imagine the horizon blazing red as the sun's edge rises higher and higher until it fills the sky. The crust would melt, the core would disintegrate, and Earth would vanish into the star that once gave it life. But if the sun's expansion is milder, Earth might escape direct engulfment. Yet this is no salvation. The planet would remain orbiting a dying giant, scorched and lifeless, a husk drifting in space. Either way, the Earth we know, the cradle of humanity, will not survive the death of the sun. And so, the question arises, what about us? Will humanity still be here when these events unfold billions of years from now? If we are, survival will depend on moving beyond Earth. Some scientists propose extraordinary engineering projects, such as building gigantic space mirrors or orbital shades to reduce the sun's heat. Others imagine constructing vast habitats in space, rotating cylinders capable of hosting entire ecosystems. These habitats, powered by solar energy, could allow life to continue even as Earth itself becomes uninhabitable. Another possibility is planetary migration. The outer solar system, once too cold for humans, may become warm enough to support life. Moons like Europa or Titan, with their icy surfaces and hidden oceans, could thaw under the sun's expanded warmth. Future civilizations might terraform these worlds, creating new havens for humanity in places that today seem impossibly hostile. Some thinkers go even further. They imagine using advanced propulsion systems to move Earth itself, gradually shifting its orbit outward to keep pace with the sun's growing size. This idea, though staggering in scale, is not entirely beyond the realm of physics. With enough time and technology, it might be possible to save Earth by guiding it into a safer orbit around the sun. But even these solutions are temporary. The sun's red giant phase will end with the loss of its outer layers, leaving behind a dense, cooling white dwarf. At that point, the solar system will be forever changed. Earth, if it survives, will be a barren rock circling a faint star. Any future humanity will need to look beyond the solar system entirely, searching for new stars, new planets, and new homes. This may sound daunting, but it also carries a powerful message of resilience. Life, by its very nature, adapts and seeks new ways to endure. Humanity's story has always been one of survival against impossible odds. From the first sparks of fire to the first steps on the moon, we have pushed boundaries to continue our existence. The death of the sun, though far away, is simply another boundary, one that challenges us to think bigger, to look farther, and to embrace the full scale of the universe. And as you're listening right now, take a moment to think about this. Every sunrise we witness is part of a countdown. The sun has already lived through billions of years, and it will continue to shine for billions more. But one day, its light will fade. That makes every morning not just ordinary, but extraordinary. If you've been fascinated so far, don't forget to like this video. It really helps more people discover these cosmic truths. And of course, subscribe to Starsky Science for more documentaries like this, where we explore not only the universe as it is today, but what it will become tomorrow. Because the sun's death is not only a story about astronomy, it is a story about us, our place in the cosmos, and our responsibility to carry life forward into the stars. While Earth will be the most dramatically affected by the sun's expansion, the story of the outer planets is equally fascinating. These distant worlds, often overlooked, will experience a very different fate as the sun transforms into a red giant. Take Jupiter, the giant among giants. For billions of years, it has orbited far from the sun, its thick atmosphere and powerful storms largely untouched by the changes unfolding closer to the center of the solar system. But as the sun swells and sheds mass, Jupiter's orbit will shift outward. It won't be destroyed, but it won't remain the same either. Its moons, particularly Europa, Ganymede, and Callisto, will be thrust into a radically altered environment. Europa, today an icy world with a hidden ocean beneath its frozen crust, may briefly warm as the sun's light grows. Imagine a time when Europa's surface cracks, releasing geysers of water vapor and exposing its subsurface seas to the universe. For a fleeting period, conditions might become more favorable for life to emerge or flourish. The same could be true for Ganymede, with its magnetic field and deep ocean layers, and even Titan, Saturn's haze-covered moon, rich with organic molecules. This raises an incredible possibility. While Earth becomes uninhabitable, some of these distant moons might actually become more habitable, for a time. They could host environments where liquid water flows on the surface, where chemical reactions spark new beginnings, and where life has a chance to take hold. It's a cosmic irony. As our world dies, new worlds may briefly come alive. Saturn, too, will experience changes. Its famous rings, composed of ice and rock, may not survive the turbulence. Over immense timescales, the material in Saturn's rings is already drifting inward, slowly raining down onto the planet. By the time the sun becomes a red giant, the rings may be gone, leaving only faint traces of the spectacular display we see today. Uranus and Neptune, the ice giants, will also drift farther away as the sun's gravity weakens. Their cold atmospheres will remain largely intact, but their distance from the bloated red sun may place them in a strange middle ground, warmer than they are today, but still far colder than any place Earth could sustain. Beyond them lies the Kuiper Belt and the Oort cloud, regions filled with icy bodies and comets. As the sun loses mass, these distant reservoirs of material will begin to disperse. Some objects may be ejected entirely, set free into interstellar space. Others will settle into new, more distant orbits, circling a dim star that was once a mighty sun. And then, the great transition will arrive. After exhausting its helium fuel, the sun will cast off its outer layers, forming a glowing planetary nebula. What remains will be a dense, collapsed core, a white dwarf. Roughly the size of Earth but with half the sun's original mass, this white dwarf will shine with residual heat, no longer powered by fusion but glowing from the last of its stored energy. The white dwarf sun will be an eerie sight. Imagine standing, if it were possible, on a surviving planet and looking up at the sky. Instead of a blazing yellow star, you would see a tiny, brilliant point of light, dazzlingly white yet small, like a cosmic ember. The warmth that once sustained Earth would be gone. The solar system would be a cold, dark place, illuminated faintly by a star that no longer lives, only lingers. White dwarfs are among the most fascinating objects in astronomy. They are dense beyond comprehension. A teaspoon of white dwarf matter would weigh several tons. Their gravity is so intense that atoms are crushed, electrons squeezed into degenerate states of matter. Yet despite their strange nature, they are common. Nearly every star like our Sun ends this way, as a white dwarf cooling quietly in the dark. Over trillions of years, the white dwarf Sun will cool further, fading into a black dwarf, an object that, in theory, no longer emits light at all. No black dwarfs exist yet in the universe, because not enough time has passed since the Big Bang for stars to cool that far. But one day, in the unimaginable future, our Sun will join their ranks, becoming a silent cinder drifting through the galaxy. This transformation will have profound effects on the solar system. The planets that remain will orbit this faint remnant, their once familiar paths altered by the Sun's loss of mass. Some worlds may escape entirely, drifting into interstellar space as rogue planets. Others will remain bound, locked in eternal, frozen orbits around a star that no longer burns. And what about the possibility of life in such a system? It may seem hopeless, but astrophysicists have speculated that white dwarfs could host habitable zones for billions of years. If a planet were close enough to a white dwarf, closer than Mercury's orbit today, it could, in theory, receive enough heat to sustain liquid water. In the future, humanity or other forms of life might seek refuge around white dwarfs, building civilizations in the lingering warmth of dying stars. Some exoplanets discovered so far orbit white dwarfs, their strange configurations offering tantalizing hints that planetary systems can persist even after stellar death. Could alien beings one day orbit our own white dwarf sun, long after humanity has gone? It's a haunting thought, that the solar system's story may not end with us, but with new life rising from the ashes. And beyond even that, the galaxy will continue to change. Our Sun, now a faint white dwarf, will orbit the Milky Way for billions of years more. It will pass by other stars, perhaps even come close enough to interact with distant systems. The scattered remnants of our solar system may one day mix with material from other stars, contributing to the endless cycle of creation and destruction that shapes the universe. In the end, the Sun's death is not just a story of loss, it is a story of transformation. The solar system we know will not survive unchanged, but from its destruction will come new beginnings. The elements forged in the Sun's core will scatter into space, enriching the galaxy with the building blocks of new stars, new planets, and perhaps even new life. And that, perhaps, is the greatest legacy of all. The Sun, for all its brilliance, is not unique. Across the galaxy, there are billions of stars, each with its own life cycle, its own beginning, middle, and inevitable end. To truly understand what awaits us when our Sun takes its final bow, we must widen our gaze and examine the cosmos itself. What we see out there, in distant star systems and galaxies millions of light years away, may very well be the preview of our own future. Let's start with the life cycle of massive stars. Unlike our Sun, which is classified as a G-type main sequence star, some stars are born far larger, burning hotter and brighter. These giants live fast and die young. While our Sun will survive for about 10 billion years, a star 10 times its mass might only shine for a few million years before exploding in a violent supernova. When we look at these events with modern telescopes, we aren't just seeing distant fireworks, we're witnessing the kinds of processes that will shape the endgame of our own solar system. The death of such stars doesn't just mark an ending, it also seeds the universe with new beginnings. Supernovae scatter heavy elements into the cosmos, iron, gold, uranium, materials that don't form in smaller stars like our Sun. In fact, the very atoms in your blood, the calcium in your bones, the oxygen you breathe, were forged in the hearts of ancient stars that died billions of years before Earth even formed. In this sense, the death of stars is not just destruction, but creation. And this brings us to a startling realization: when the Sun eventually dies, it will not create a supernova. It's not massive enough. Instead, it will expand into a red giant, shed its outer layers into space, and leave behind a dense remnant, a white dwarf. At first glance, that sounds almost peaceful compared to the explosive deaths of massive stars. But don't be deceived, what happens to the planets during this transformation is anything but gentle. Earth, by this point, will be unrecognizable. Long before the sun becomes a red giant, our oceans will have boiled away, the atmosphere will have collapsed, and the surface will be scorched beyond recognition. When the sun swells, Mercury and Venus will be swallowed entirely. Whether Earth meets the same fate depends on complex interactions, tidal forces, orbital changes, and mass loss from the sun. Some scientists suggest Earth might be engulfed. Others propose it could barely survive, left as a burned, lifeless rock circling a dying star. Either way, life as we know it will not survive. But here's a fascinating twist: while the sun's expansion spells doom for the inner planets, it may offer opportunity for others. The icy moons of Jupiter and Saturn, Europa, Enceladus, Titan, currently locked in deep freezes, could warm dramatically. For a brief cosmic moment, liquid water may flow on their surfaces. In that window of time, new ecosystems might emerge. Imagine life not ending with Earth's demise, but instead shifting outward, carried by the sun's last great act of transformation. This idea has fueled speculation among astrobiologists. Could intelligent life, if it survives long enough, migrate outward to these worlds? Could humanity, or its descendants, find refuge in the outer solar system as the sun swells? The timescales are daunting, but the principle remains: death for some worlds may mean opportunity for others. And yet, the white dwarf phase is the ultimate curtain call. After the sun casts off its glowing outer shell, what astronomers call a planetary nebula, it will leave behind a corpse of a star, small yet immensely dense. Imagine something the size of Earth, but containing nearly half the sun's mass. In this state, the sun will no longer produce fusion. It will simply radiate the last of its stored heat, slowly cooling over trillions of years, fading into darkness. This is the quiet, inevitable fate of our star. Not a spectacular explosion, but a long fading whisper into the night. And in that silence, the solar system as we know it will vanish. But the story doesn't end there. To truly grasp what this means, we must look beyond even the sun's death and consider the cosmic timescale. You see, the death of stars sets into motion the destiny of galaxies themselves. Over billions of years, galaxies burn through their star-forming fuel. Stars die faster than new ones are born. And eventually, the universe heads toward a future where the lights go out everywhere. This concept, often referred to as the heat death of the universe, paints a chilling picture. All stars fade into white dwarfs, neutron stars, or black holes. No new stars form. Galaxies grow dark. Energy spreads thin across an ever-expanding cosmos. If the sun's death feels personal, the death of the universe itself is the ultimate reminder of impermanence. Yet, within this bleak vision lies something profound, the recognition that we are living in a very special era of cosmic history. Right now, the universe is vibrant with stars, galaxies, and life. This golden age of cosmic activity won't last forever, but we happen to exist within it. And that raises a question, one for you, the viewers of this documentary, to consider deeply. If the universe itself has an expiration date, what should we, as conscious beings, do with the fleeting moment of time we're given? Share your thoughts in the comments below. I'd love to hear your perspective on whether humanity should embrace exploration, or simply treasure the fragile beauty of the present. And while you're here, don't forget to like this video. It helps the channel grow and brings these cosmic stories to more people just like you. Now, let's return to the science. To understand the sun's eventual demise more precisely, astronomers turn to a category of stars known as solar analogs, stars nearly identical to our sun but at different stages of their lives. By studying them, scientists essentially look into a crystal ball. For example, stars slightly older than ours show the swelling and instability that foreshadow the red giant phase. Others, now white dwarfs, give us a direct preview of the sun's ultimate end state. NASA's Hubble Space Telescope has captured breathtaking images of planetary nebulae, ghostly shells of gas cast off by dying stars. These images aren't just beautiful, they're snapshots of the sun's future. And in each glowing cloud, we see not just death, but transformation. For the gases expelled into space don't simply vanish, they mix with interstellar material, seeding future generations of stars and planets. In this way, the sun's death ensures that life, somewhere in the galaxy, may one day rise again. Even now, astronomers debate the details. How exactly will the sun shed its outer layers? Will Earth survive the red giant phase or be consumed? What will happen to the asteroid belt, the Kuiper belt, and the Oort cloud? Each question drives new research, new simulations, and new discoveries. And with every answer, we refine our vision of the future. If the sun's death is inevitable, the question becomes, what will humanity do about it? Will we vanish along with Earth, or will we rise to meet the challenge of cosmic survival? For centuries, these ideas belonged to the realm of science fiction. But today, with rapid advances in space exploration and technology, what once seemed impossible is slowly shifting toward the realm of possibility. The death of the sun may be billions of years away, but the choices we make in the coming centuries could determine whether our species has a future beyond Earth. The first and most obvious strategy is colonization of other worlds. For a long time, Mars has been the focus of human imagination. It's close enough to reach with current technology, yet distant enough to escape some of the sun's growing fury. But as we've learned, Mars has its own challenges: thin atmosphere, low gravity, lack of a protective magnetic field. It's not a paradise waiting for us, it's a harsh world that would require massive engineering efforts to make habitable. Still, Mars represents a critical stepping stone. If humanity can establish a sustainable colony there, it will prove that we can live beyond Earth. That achievement alone would mark the beginning of humanity as a multiplanetary species. But Mars is just the beginning. As the sun expands, even Mars will eventually become too hot to support life. This means humanity will need to move further outward. The icy moons of the outer solar system, Europa, Ganymede, Titan, and Enceladus, offer fascinating possibilities. Beneath their frozen surfaces are vast oceans of liquid water, kept warm by tidal forces and internal heat. In a future where the sun grows brighter and hotter, these worlds could transform into habitable environments. Imagine domed cities floating on Titan's methane seas, or underground colonies thriving in the salty oceans beneath Europa's ice. Such visions sound futuristic, but they're grounded in real science. NASA and ESA missions are already studying these moons, searching for signs of habitability, and perhaps even existing microbial life. But surviving the sun's death may require humanity to go even further, beyond the solar system itself. To do that, we must face one of the greatest challenges in history: interstellar travel. Right now, our fastest spacecraft, Voyager 1, has taken more than 45 years to travel just 24 billion kilometers. That's less than 0.05% of the distance to the nearest star. To escape the sun's ultimate fate, we'll need propulsion systems far beyond anything we've built. Scientists have proposed bold ideas: fusion-powered spacecraft, antimatter engines, even light sails pushed by powerful lasers. These concepts remain theoretical, but progress is happening. Projects like Breakthrough Starshot are already exploring how tiny probes could be accelerated to 20% the speed of light, reaching nearby stars in a human lifetime. If that technology can be scaled up for human missions, interstellar travel might not remain fiction forever. Of course, escaping the sun's death isn't just about propulsion. It's about survival across unimaginable timescales. One possible solution is the creation of generation ships, massive space habitats where thousands of people live and die over centuries, with new generations carrying humanity onward. These ships wouldn't just be spacecraft, they'd be miniature worlds, complete with ecosystems, agriculture, and artificial gravity. But here's a fascinating twist: some scientists suggest we may not need to leave the solar system at all. Instead, humanity could build artificial habitats, structures so vast they could house billions of people, powered by the sun's energy until its final days. Concepts like the O'Neill cylinder or the Dyson swarm illustrate what's possible. Imagine countless rotating space habitats orbiting in a swarm, collecting solar energy, and sustaining entire civilizations in space. Even when the sun becomes a red giant, these habitats could migrate outward, staying in the habitable zone as it shifts past Earth and Mars. Humanity, in this vision, becomes not a planet-bound species, but a stellar species, living wherever conditions allow. And yet, the end of the sun will eventually demand a bigger leap. As the sun transforms into a white dwarf and its energy fades, the solar system will become a dark, cold place. At that point, humanity must either move to another star system, or harness new sources of energy, like tapping black holes or mastering fusion on a galactic scale. It's almost overwhelming to imagine. But here's the truth: every step humanity takes today, developing clean energy, advancing artificial intelligence, building space stations, could be laying the groundwork for this distant future. Now, let's pause for a moment and consider something profound. The sun doesn't just give us warmth and light, it defines who we are. Our myths, our religions, our calendars, our very biology, all shaped by its rhythms. When the sun dies, it's not just a physical event, it's a cultural and existential turning point. Will humanity adapt? Will we find a way to preserve our heritage among the stars? Or will we vanish, leaving only traces for future civilizations to stumble upon? These questions remind us that survival isn't just about science, it's about meaning, identity, and the will to endure. But here's a remarkable thought: if humanity does survive, if we do spread beyond the solar system, we may live to see the deaths of countless other stars. We may witness supernovae up close, harness the power of neutron stars, and perhaps even learn to manipulate black holes themselves. The death of the sun, then, isn't just an ending, it's a test. A gateway. The challenge that determines whether we remain bound to Earth, or ascend to become a truly cosmic species. And this brings us back to the present. Because while the sun's death may be billions of years away, the choices we make in the next few centuries matter more than ever. Will we invest in exploration? Will we protect our planet long enough to build the tools we need? Or will we fall into extinction long before the sun ever threatens us? In the vast timeline of the cosmos, our moment is brief. But within that brevity lies the power to shape the future. The sun will die. That is certain. But whether humanity dies with it, that remains unwritten. The story of the sun's death is, in many ways, the story of the universe itself. Stars are born, they shine, and eventually, they fade. Their endings give rise to new beginnings, seeding galaxies with the elements of life. Without the deaths of ancient stars, Earth would never have existed. You would not be here, listening to this story. I would not be here, telling it. And so, when we speak of the sun's inevitable end, we're not just talking about destruction, we're talking about the continuation of a cycle far bigger than ourselves. It's humbling, and it's beautiful. Scientists often describe the sun as ordinary. It's not the largest, brightest, or most unusual star in the galaxy. And yet, for us, it's extraordinary. It has fueled every breath of life on Earth for billions of years. It has given rise to civilizations, guided explorers, and inspired myths that stretch back to humanity's earliest days. To call the sun ordinary is to overlook just how deeply it has shaped our existence. When the sun eventually becomes a red giant, swelling to unimaginable size, it will erase the world we know. Oceans will vanish, skies will collapse, mountains will crumble under the heat. Earth, if it survives engulfment, will be nothing more than a charred relic. But in that same transformation, new possibilities will bloom in the outer solar system. Worlds once frozen may thaw, giving rise to oceans and, perhaps, life. The universe does not simply close doors, it opens new ones. Yet even that stage won't last. The sun's final act will leave behind a glowing nebula, brief, by cosmic standards, and then a silent white dwarf. A star reduced to an ember, cooling for trillions of years until it disappears entirely. That is the destiny of our star. But here's where the story becomes bigger than astronomy. The sun's death raises a question that goes beyond physics or astrophysics. What does it mean for us, as a species that can anticipate the future? We are, as far as we know, the only form of life that looks up at the stars and wonders not only where we came from, but where we are going. It is a heavy burden, knowing that our home is temporary. But it is also a gift. Because to know the sun will die is to be reminded that our time is precious. The billions of years before its end may feel endless, but for us, tiny flickers of consciousness, the timeline is short. We are here for a brief cosmic moment. What we do with that moment defines us. And so, when we talk about the sun's fate, we are also talking about our own choices. Will we use our knowledge to preserve the planet, to expand beyond it, and to secure a future for life among the stars? Or will we waste this moment, allowing short-term struggles to eclipse the long-term survival of our species? The story of the sun's death is more than just science, it's a reminder of how fragile, yet extraordinary, life really is. Our star, the giver of light and warmth, is living on borrowed time. And when its fire fades, everything we know will change forever. But here's the most powerful truth: while the sun's end is inevitable, our own fate is not. Humanity still has the power to adapt, to explore, and to carry life into the farthest corners of the universe. Whether we remain bound to Earth or become a species of the stars, that choice lies in our hands. So, the next time you look up at the sun, remember this: it is not eternal, but it is enough. Enough to give us life, enough to give us meaning, and enough to give us the time to decide what kind of future we want to build. This has been Starsky Science, where we uncover the mysteries of the universe, one star at a time. If this video sparked your curiosity, don't forget to like the video, share it with others, and subscribe to the channel so you never miss the next cosmic story. Because the sun may be dying, but our exploration of the universe is only just beginning.